Hey guys, I'm so sorry to be out again this afternoon. I have a department chair meeting that I need to attend. So you guys are going to learn about functions without me, and then we will continue working with this some more in ASA tomorrow. Focus, pay attention, take good notes, and good luck. You learned about functions last year, so hopefully a lot of this will feel very familiar to you. Before we talk about functions, let's talk about relations. A relation is a set of ordered pairs. Make sure you write that down on your note sheet. There's an example in red down here at the bottom. Literally, it's just a list of ordered pairs. So on this slide, you see that same relation being shown a bunch of different ways. We can see it as a set of ordered pairs at the top, as a table on the left, or as a graph on the right. Okay, let's pause with all the math stuff and talk about snacks for a second. So take a look at this vending machine. You've got a whole bunch of different snacks in here. And if you look at the prices, we've got all these different prices. We've got 55 cents, 75 cents, 45 cents, 30 cents, 25 cents, 90 cents, 70 cents, 50 cents, and 85 cents. Notice all the prices are different. You're going to put in however much money you need for the snack that you want, and then you'll get out the snack that you want, right? So each thing costs something different. But now take a look at this vending machine. Notice how some of the snacks cost the same amount. Like you can see the glass bottle of soda and then the can of soda both cost 75 cents. So if you put 75 cents into this machine, obviously you're going to select which one you want, but you could really get either one. So there's a difference between the vending machine on the previous slide and this vending machine. And that's going to be the difference between relations and then what we call functions, which we'll learn about on the next slide. A function is a very specific type of relation. It is a relation in which for every x value, there is exactly one y value. So no x value is used more than once. So go back and think about the vending machines. The first one, remember, all of the items had different prices. The second one, some of the items had the same price. The first vending machine would be an example of a function because every input value has exactly one output value. The second example is not a function. We would just consider that just a plain old relation. It's not a function because there are some inputs, 75 cents being the example we were talking about before, that will get you two different outputs. It'll get you two different types of soda, right? The bottled soda or the canned soda. Make sure you write down the definition of function on your note sheet. So in this slide, we have two different relations being shown, one in pink on the left-hand side and one in blue on the right-hand side. Which one is not a function? Remember, a function should not have any repeating x values. The blue one is not a function. So the pink one is a function because none of the x values repeat. The blue one is not a function because x equals -3 is used more than once. At one point, x equals -3 gets you a y value of 1. At another point, x equals -3 gets you a y value of 3. So the blue one is not a function. Just like with relations, you can represent functions a bunch of different ways. Here's a couple ways that we see them pretty commonly. We can represent functions as equations, on a graph, as a table, as a sentence, like written out in words, or as just a set of ordered pairs. In the middle of your note sheet, you have examples of functions and not functions, and they're written in a bunch of different ways. We've got ordered pairs, a table, and then a mapping. The mapping has two different ovals, like the one on the left is the x values and the one on the right is the y values, and those arrows are showing which x values go to which y values. I want you to pause this video and take a second to really examine the not functions column. Go ahead and circle what ordered pairs or rows in the table or parts of the mapping is making it so that that particular relation fails the idea of being a function. Remember, functions have no repeating x values. Go ahead and try that out. Go ahead and check your answers with what I have up on the screen. You can see exactly why each of the relations on the right is not a function because of the repeated x values that exist. So notice in the previous set of examples that we didn't actually look at any graphs. That's because the graph has a different way visually to test whether we have a function or not. So if you take a look at the two graphs that we have on the screen, these same graphs are on your note sheet. What we're seeing here is the one on the left is a function and the one on the right is not a function. Do you see how the one on the right, we have that green line drawn in there? That green line is showing that the 2 points touching that green line have the same x value, right? Remember, x values are lined up vertically. So those 2 points actually have the exact same x value, but they have different y values. And that's what makes the one on the right not a function. So the vertical line test is what we actually use to determine whether a graph is a function or not. If the graph is a function, the vertical line will only pass through 1 point at a time. So thinking about the examples that we saw on that previous slide, the graph on the left was a function because if you take a vertical line and move it across that graph, which is the curvy part, it'll never hit more than once. You can use your pencil as your vertical line there. The one on the right, it will fail the vertical line test, and it fails the vertical line test at that green line because do you see how the green line actually hit the graph more than once at the same time? That's the problem there. It's making it so that we have multiple y values for the same x value. Make sure that you copy down the definition of the vertical line test on your note sheet. Let's try out the vertical line test. So watch as the vertical line moves across the curve. It never hits 2 points at the exact same time on this curve. So since it passes the vertical line test, it is a function. Now check out this one. This one is not a function because that vertical line is hitting 2 points on the graph at the exact same time. So that specific x value has 2 different y values at the same time, and that makes it not a function. Think about this one. Is it going to pass or fail? Let's check it out. Move your vertical line across the screen. It passes the vertical line test, so this is a function. So let's check out this one. This one is going to fail the vertical line test in a bunch of different places, but here is just one example of where it fails. You can see the line is actually hitting the graph in 3 different places for the same x value. When x is 2, there's a y value of maybe like 5.3, 4, and -4 down towards the bottom. So it is failing the vertical line test, and that makes it not a function. For this one here, imagine that the entire graph is just a blue oval or a red oval. It's just the program that we use to make the graph that's making it this way. But let's move the vertical line across the screen. It's going to fail a bunch of times. You can see right here at x equals -2, it's got a y value of maybe 3.5 and -3.5. So we've got 2 different y values for the same x value. That means the x value is repeating, so it fails the vertical line test, so it's not a function. This one here is going to pass the vertical line test because it never hits twice. So this is a function. This graph here is like the ultimate fail. So it's going to fail at every single point on that line because the line was a vertical line. Vertical lines cannot be functions. So this fails the vertical line test. That same x value, x equals 4, has infinite numbers of y values that goes with it, and that makes it not a function. This one here is going to pass the vertical line test, never hits more than once. So this is a function. This one here is what we call a discrete graph. It's just a whole bunch of distinct separate data points on here, but we can still use that vertical line test. And you can see that it's never going to hit more than once. So this passes the vertical line test and therefore is a function. This one here is going to pass that vertical line test. It's a function. Here's the discrete graph that's going to fail the vertical line test, and it fails at several different points, but this is the first time that it fails when x is 0. When x is 0, it's got a y value of 6, 7, and 8. So we've got 3 different points hitting at the same vertical line, and that makes it so that it's going to fail that vertical line test. That means it's not a function. If you keep looking, it's also going to fail when x is 1, when x is 3, when x is 4, when x is 5, and then when x is 7. So it's going to fail a bunch of different times. All it has to do is fail once, and it is not a function. This graph here is really unique. So look at where x equals 1. Do you see how it looks like there's 2 points where x is 1? There's that 1, 2, which is a filled in point, and then there's 1, 3, which is an open circle there. We actually call that open circle a hole in the graph, and it really means that the graph is not defined right there. So when you are thinking about the actual relation itself right here, when x is 1, the only y value that goes with that is 2. Y equals 3 doesn't actually go with x equals 1, okay? And that's because there's a hole at the point 1, 3. So basically what that means is this horizontal line right here that stretches from x equals 1 to x equals 5, it is not defined where x equals 1, but where x equals 1.0001, it's defined as y being 3. So that's what the hole in the graph actually means. So think about what that means as far as passing the vertical line test goes. So when you do your vertical line test right there, do you see how it's going to, like, that's going to kind of trigger your thoughts of it maybe failing? It's actually going to pass because it's not defined at 1, 3. It's only defined at 1, 2. So technically, this graph passes the vertical line test, and that means that it is a function, and that is all a result of that hole in the graph at 1, 3. So major takeaways about functions, what you need to know. You need to know that a function has no x value that has more than one y value. So none of the x values are going to repeat. All right. And then if you're looking at it on a graph, it's going to pass that vertical line test. Looking at repeating x values is more helpful when you have like a list of ordered pairs or you have a table or a mapping. Looking at the vertical line test is more helpful when you actually have a graph. So it's really a couple different ways of thinking of the same idea that no x value has more than one y value.